Hello guys, today we are gonna do a really fun topic. It might be a little boring, but if you understand it, it's really good and it's really amazing. So let's start it without any delay. So we are gonna study today fluid kinematics. So what is fluid kinematics? Fluid kinematics deals with the motion of fluid, which you know, kinematics, study of motion and of fluid. So yeah, that's basically it. Motion of fluid, study of motion of fluid. So firstly, the primitive idea which came was Langrangian method, and Euler method or Euler method. So the Langrangian method said that we can calculate fluid kinematics is basically deals with the velocity, the acceleration, etc. This avoids dealing with forces. Like it deals with the velocity, the acceleration. We will find how the motion works. We are not going to study of the forces, which the external force which is given into it. We are not going to study about that. We are going to study the kinematics, like how this thing the equations, how we can solve them, and how we can solve the complex numericals with this. How can this help in our real life? We can do some applications. We will do that further later. But first, for the primitive idea, we need to learn Langrangian method and Euler method. Langrangian method is pretty much nothing that it says that if there is let us take an elementary structure, an elementary box, a cube or something else, and this is the fluid, okay? A particle, there are numerous particles, like a huge number of particles, right? Like, see it as a drop of water. There are numerous particles, right? Langrangian method says that we can calculate every position and we can calculate the velocity, acceleration of every particle, right? We can find it, but in reality it's not impossible, but it's really hectic, isn't it? So it's pretty much doesn't do anything, but yeah, theoretically it's correct, we can. But this Euler method is pretty much a little effective and it's efficient, and it really helps us in most of the things. Most of the equations are made of this Euler method, based on Euler method. So this thing, we will just rub this off. What does Euler method suggest? States that we can take a field variable. Now, what is a field variable? Field variable is a type of variable which is a function of the particle. Like this, like if there is a particle, then it depends on something, right? It depends on the position, it depends on velocity of the fluid. If the velocity of the fluid is very much more, then the particles will move faster, right? The rate of volume flow of fluid will be more if the velocity is more. So like that, field variable can be anything, okay? Field variable can be anything like pressure, velocity, acceleration, etc., like this, okay? So we will take an example for that. Field variable can be anything, but with this field variable we can find any particle's position, velocity, acceleration at a particular time, and that's real fascinating, isn't it? So like if we take like velocity is a function of x, y, z, t. Now velocity is a field variable. Again, pressure, f, x, y, z, t. Pressure is a field variable. Like see, we will take an example, a very easy example. Suppose this is elementary volume as a fluid. Suppose here is a particle, right? If I say that it is, if I take this as origin, it is 5 meter. I'm just taking an example. It is, of course, it's not going to be 5 meter because it's elementary. I'm stating it first, right? 5 meter from here, this is x-axis. 5 meter from here, which is y-axis, and z from here, 5 meter. So what is the position of this? 5, 5, 5, right? This is this simple, this much simple. And at time, let us suppose 10 seconds. Okay, at the 10th second, the position of this particular particle is 5, 5, 5, 10. And this is, we found this. This is a field variable. This depends, this pressure and volume depends on these, right? Because how? See, 5, 5, 5 are coordinates, right? X coordinate, y coordinate, z coordinate. So if we find the vector form 5i cap plus 5j cap plus 5k cap, and then we take the modulus, so root over 5 square plus 5 square, 5 square, whatever it is, that's a magnitude, and that's a value, right? That value is this variable's value, right? This variable's value at the particular time. This t is also a factor. There are 4 factors. See, there are 4 variables which give value to this variable, and that's why this variable is the function of x, y, z, t, because these values, when put into the function is a device which puts into the function. We take a mixer grinder, we take these ingredients x, y, z, and t, and when we grind them, we get the velocity, we get the pressure, we get this, and also we can get acceleration. We differentiate velocity and then we get acceleration. That's that simple. And these are the field variables which Euler mentioned. And like this, we can get any particle. Now see, this is flowing, right? If we say uniform, this is a uniform fluid. We will talk about uniform fluid right now. After this, what are those? But let us take, this is a uniform fluid, and all fluids are going, and they do not change with respect to space. And every particle which comes at this point, at this coordinate 5, 5, 5, right? At 5, 5, 5, the velocity is that root over 5 square plus 5 square plus 5 square, isn't it? So that's why, that's the thing. And now, like this, Euler methods, this is the Euler method, and like this, the advanced equations and the numericals are solved, and the equations are also based on this.